Chapter 9 is all about understanding randomness. So what does it mean to be random? Well, for something to be random, we can know its probability, but it's kind of like a coin flip because, as you learned from your homework, a coin flip is a random event. Although we might know its probability, the outcome can't be predicted, uncertain, and whatever it is random. They don't have to be even. You can look at winning the lottery. Winning the lottery is kind of random. It's just pure chance. And so when we think about how winning the lottery is random, you don't have an even chance of winning the lottery and not winning the lottery. You're just trying to guess the right random numbers that it might be. So it's pretty random to win the lottery. It's all luck and complete random to win the lottery. So random is great for statisticians because when something is random, we can actually use it to describe events. And we see this in simulation. And that's where we get into the next very important topic. Simulation is something we can do ourselves. We can do it with computers, or we can run our own simulation. And we can do this with sites like random.org. So here on random.org, we can generate random numbers. And let's go ahead and generate numbers between 0 and 9. And with this right here, these are 10 numbers. And these numbers are often used because when you think about it, if you start writing down numbers 0 through 9, you don't have to write down 2-digit numbers. If you write down 10, that is a 2-digit number, and all of a sudden now things get a little bit confusing. We also have random number tables, which you saw on your last homework assignment with rolling the dice. You were given a random number table and asked to use those numbers. And sometimes that's how we do it on the test. We can ask you theoretical ways of doing stuff. We can make you come up with your own random numbers or stuff like that to show you understand how simulation can be done. And this has a lot of real-world applicable use. So let's give it a try here. Let's go ahead and simulate something my class did here. Let's simulate going to McDonald's, and we want to get a winning prize from McDonald's Monopoly. So McDonald's Monopoly has let's say a 1 in 10 chance of winning a free meal. Like, you can get a small thing, but you can get a free meal. And so you are going to go every day for a week. And you want to see how often you win a free meal, and you're going to do it over 2 weeks. So go ahead and write down these numbers as I do this for this simulation. The first thing we need to figure out before simulating is what's going to be a winning number. If the chances of winning is only 1 out of 10, well, we only need to pick one number as the winning number. Now, it's actually arbitrary what number we pick as the winning number. We could pick 5 or 6 or 7, but a lot of times I like to pick something near to the end, like 0 or 9. So that way we could do 0 is, winning a meal. We could do 1 and 2 is winning a smaller item. Let's do that. Let's do 0 is winning a meal, and 1 and 2 is winning a smaller item. So now from McDonald's Monopoly, there is a 10% chance you win a meal, and there is a 20% chance you win a smaller item. Winning a meal and winning a free food item are actually disjoint because you can't win a meal and a little item in one ticket. We're counting it as, did you win a meal or did you win a smaller item like a fry or an apple pie? I'm hungry right now. So with this in mind, 10% chance you win a meal, 20% chance you win some sort of small food item. Now, number 0 will be winning the meal. 1 and 2 will be winning the small food items. Keep track of these numbers, and let's look what happens over the course of a week. First day. Whoa! It's my lucky day. I like that. Next. I swear I am not rigging this. This video is not edited. If I get another free meal, it's going to be crazy. And actually, I want to pause there. There was 2 free meals. But the chances of me winning that third free meal was actually 1 in 10. Because that would be not the law of averages, because it was just one event right there. It was independent of the previous events, and so I wish I'd won that third free meal. Dang, I feel like I lost. I did lose. 8 lost, 9, and 0. Whoa! I won 3 free meals this week. That is amazing. So I didn't even win any small food items, which were actually more likely to be won than the free meals. And now we simulate again. 9, 7, that's third. 739. So now I need 2 more. There's a free meal. And so I won 1 free meal this week, and I don't think I've won any small food items. So if I was writing this down, I'd make sure to write down the first week I won 3 free meals, and the next week I won 1 free meal. And so you see I'm simulating 7 numbers here to generate how many free meals I'm winning. I could also write down how many small menu items I win. And funny enough, I've won 0 small menu items, which have a higher likelihood. Let's simulate here again. Let's check out another week. There's a small menu item. So now I won 0 free meals this week. So first week, 3 free meals. Second week, 1 free meal. Third week, 0 free meals. And this week, I also won 1 small food item. And you can just keep track of what happens in this simulation. We could ask you questions like, on average, how many meal items are you winning a week? And this is meals. So we won 4 meals over 3 weeks. So we're winning 1.33 meals a week because there were 4 free meals won in our simulation, and we simulated 3 weeks. That's 1.33 meals on average. We could ask you, how many items do you win per week on average? And this time, we would be looking at how many meals and small items. We could combine those together, like how many meals and items do you win per week? Just how many times do you win? And that would be 5 over 3 because we won 5 things total. 3 meals first week, 1 meal second week, 0 meals the next week, and 1 free item that final week. And so that would be 5 over 3, so 1.66. So this is an interesting simulation right here, and you could do it with anything. You could say, I want to draw M&Ms out of a jar, and there are 5 colors of M&Ms. What is the probability that in my handful of 6 M&Ms, there's 2 blue ones? And really easy way to do this simulation, we can change the numbers. You can always change numbers. If there's 5 M&Ms, we can say 1, 2, 3, 4, 5. And we could simulate 6 M&Ms in your hand and see if you can get 2 blue. So now in this simulation, I want to do, let's do 4 M&Ms so I don't have to simulate that many. 4 M&Ms, and we want to see if you get 2 blues. So blue will be 1. So you could name them all different colors, but I can just pretend the number 1 is blue here, and I can simulate 4 M&Ms in your hand. So that's not blue, not blue, not blue, and we did not get 2 blues in our hand. So this is kind of like this serial question you did where you can just put an X down right now. We did not get 2 blues. And we simulate another handful of 4 M&Ms. Blue. There we go. We got 2 blues at least. So this could say at least 2 blues on the problem, something like that. But we got 2 blues in our hand, so I'd put a check down. So in this little handful of M&Ms, or little handful of M&Ms, only 4, we got 2 blue M&Ms. And I'd put a check down right now. So right now, out of our 2 simulations, 1 time we got 2 blues in our hand. So right now, 50% of the time, because 1 out of 2 times we got 2 blues. So the question for this could read, you are simulating picking up M&Ms out of a bag, and you're only going to take 4. How often do you get 2 blue with the chance of blue being 20%? And so we're just simulating here. We'll do another handful. Not blue, not blue, not blue. And we got 1 blue. So we have only gotten 2 blues 1 out of 3 times now, so it'd be a 33% chance. A lot of good stuff like this. We could say, how many blues do you get on average? So we've got 3 blues out of the 3 hands, so that'd be 1 blue on average. So lots of interesting ways to ask the questions. Just try to make sure to simulate within the bounds of what we say. Try to come up with your own simulation questions and practice the ones we've given you and the ones on the practice test. Good luck, and email me if you have questions.